Yesterday, we started talking about trig identities and we were simplifying them. We're making them smaller. Today, we're going to do something called proving. And actually, all right, we're going to go, I could do 100 examples and they're all a tad bit different than the previous one. So this is not the easiest thing in the world, I know that. But if you can follow these little guidelines, it makes things a lot easier. All right, the first guideline says start with one side. You want to pick one side of the equation that looks to be more complicated. You'll see what I mean in a second. Then you need to know how to use your identities. You guys are going to have all the identities on your desk while you're working through the whole test, so don't worry about that. But think about things algebraically. I'm going to keep saying that 100 times. I'm going to bring up some examples as we go through. You want to think algebraically. When I say think algebraically, guys, if you have a fractional exponent, right, we want to get rid of denominator. I mean, if you have a fraction in your problem, you want to get rid of the denominator. If you're adding or subtracting fractions, you get a common denominator. If you can factor something, factor something. All of the different things that you can do and you've done algebraically, you can do with these trig equations. It's harder to see. All right, and the last thing, this is from the book, guys. It says, if you are stuck, rewrite all functions in sine and cosine. Sine and cosine are your most basic trig functions. So if you're sitting there looking at a problem, you're like, I don't even know where to begin. Convert to sine and cosine. Something will present itself like, oh, okay, that makes sense. Some of you are going to see these problems and look at it and think of it in one way. Some of you are going to see another path. That's okay. There's a bunch of different ways to solve this, but you have to try and do something. Sam, you with me? Okay. All right, let's look at number one. Yeah.
Is this 7-1?
Yeah, this is just the last three examples. Just scroll to the end. All right, if you don't have this, guys, I will give you this sheet. I like this one better. I actually have one that I think is even better that I might talk to Ms. Glick about giving you guys. But take a picture of this and put it next to every single problem we do. You will start to see patterns. You'll start to see repetition. You'll start to know, oh, this is 1 over that, whatever. But until we get there, let's have our identities right next to us. All right, so the first thing I'm going to do is I'm going to rewrite the problem over here. Now, this says cosine, and they use theta. All right, if you want to use x, if you want to use a smiley face, I don't care. Just as long as you have something to denote an angle measure.
Do you mean for the final answer I have to put theta?
No. I'll use theta because it's what's in the problem, but for later problems when they use different letters and stuff, I don't like that. I always change it. If you want to use x, that's fine. All right, so we are proving. This is a trigonometric proof, just like in geometry. So you got 2 columns. All right, so now, which side, always ask yourself, which side looks more complicated? The left-hand side, okay? So let's leave sine squared alone. We are trying to prove, they're already telling us from the very beginning, guys, the left-hand side is equal to the right-hand side. They're telling us that. We know that it's true. So now let's try and simplify. So think about our most basic trig functions are sine and cosine. First thing I ask myself is there a trig function that is squared that's attached to a plus or a minus 1? No. So I can't use my Pythagorean identities. So I'm going to leave cosine just like it is because there's nothing to do with cosine. 1 over secant's not going to help us at all. So let's go inside our parentheses. What can you change secant to? 1 over cosine, agreed. And we're just using our identities. Then I have minus cosine theta over what number? Over 1. Okay, fine. Leave cosine out here, just hanging out. And now I look on the inside. What are you doing on the inside here? Subtracting what? Yes, but what are those things? Those are fractions, aren't they? If you had 1/2 minus 1/3, you'd get a common denominator. What is your common denominator going to be between cosine and 1? Cosine. All right, so I'm going to just, my common denominator. Okay, cool. Write it a little bigger. All right, so cosine is my common denominator. So I look at the first fraction. It has cosine already, correct? Yeah. So I don't need to do anything to the numerator. I just leave it.
1 minus cosine.
So good. See, some people just see it. Now, what am I going to do on the right-hand side? I need a what? I need a cosine, right? What you do to the bottom, you do where? to the top. What's cosine times cosine? Cosine squared. All right, now keep in mind, we're trying to get to sine squared. That's where we're going. Yes, ma'am? Say it again. Because we're getting a common denominator. Like if I had 1/2 minus 3/5, we'd get a common denominator, right? We'd say our common denominator was 10. So 2 times what gives me 10? You'd say multiply by 5 on the bottom, then a 5 on the top. Here, I'd multiply the bottom by 2, so I'd multiply the top by 2, right? Same concept.
How come you didn't like cosine in the first parentheses? Like you put 1 over cosine theta, and then you put cosine theta over 1.
Because that second cosine theta, I just put it over 1 so I could see it better.
Oh, so you don't have to.
You can just leave it like that. No. So now, guys, go to you're looking. You're like, okay, what can I do? First of all, what can you do?
Can you cancel out?
Can I cancel out this cosine that's on the outside here with the one on the bottom? Yeah, because you're just multiplying. So there you go. Those cancel out. So you're left with just 1 minus cosine squared. Look at your Pythagorean identities. Is there something in the Pythagorean identity that has a cosine squared and a 1 in it? Yeah. Which one? Sine squared plus cosine squared equals 1, right? So what can I do to that formula to manipulate it so it says 1 minus? Subtract the cosine from both sides. Agreed. Good, guys. So this goes away. So you're same exact. This means the same thing as the original. It's just written a different way. What can I replace this with? Sine squared. So I have sine squared theta over here. And what does it say over here? Equals sine squared theta. Now, guys, this is what a lot of you will do. All right, grading this is not super fun for me. Takes me a minute. But some of you will start this problem off and just write at the bottom, sine squared equals sine squared. They do a check mark and then just like copy stuff from the identity sheet in the middle and be like, oh, she probably won't look. She's going to look, guys. It takes me longer to grade these, but this is your answer here. How you showed me that the left-hand side is equal to the right-hand side is the answer. Sine squared equals sine squared is not the answer. I already know that when the problem begins. I know that the left-hand side equals the right-hand side. You have to show me why in the middle. Now, for the problems that Ms. Glick and I give you, you should not use more than 3 or 4 steps. Now, there are times when you take the wrong route and then you end up in the right spot, but it took you a lot longer. Hang on one sec, Marcel. But for the most part, you should be able to concisely do this in 3 to 4 steps. Yes, you can go. All right, we're going to do more examples today, and then we're going to do more examples tomorrow, and I'll give you more examples to practice. This is all we're doing this week is this and one more little thing starting on Thursday. All right, next one. Okay, so here we go. First step, I'm going to rewrite it so I can write it like a little trig proof here. Actually, yeah, I'm going to rewrite it. So cosine, I'm going to say theta. Whoops. Over 1 minus equals secant theta plus tangent theta. Now, last period, I said, guys, just look at this for a second. Like I said, you'll start to see stuff. Just looking at the left-hand side and looking at the right-hand side. Which one looks more difficult? The left. How come? Because there's a fraction. As soon as you guys see fractions, like, ugh. Another reason the left-hand side's harder is because there's a minus sign in there. You can't just cross stuff out. But looking at the right-hand side. All right, we're always going to start on the harder side. But just thinking ahead, what is secant the same as? 1 over cosine. Okay, and what's tangent the same as? Sine over cosine. Okay, just kind of think. Like, look at what you have and kind of think. All right, now, guys, every time you start with a fraction with a denominator that has 2 terms, do you guys see how there's a 1 and the sign, and it's connected by a negative sign? You can't split that up, but we're going to get rid of it. 1 minus sine theta, that's not a Pythagorean identity, okay? It's not. When you start with a denominator that has 2 terms, you always want to multiply by the conjugate. Do you remember when we had 3 plus 4i and then 2 minus 6i? We wanted to get the i's to cancel out. What'd you have to multiply? 2 plus, right? The conjugate. You got those i's to cancel out. You do it to the bottom and the top. Same concept. Remember, we're thinking algebraically. I want to get this denominator to somehow cancel out, somehow go away. So I'm going to multiply by the conjugate. You're going to do this every time you start off with a denominator that has a 1 and a minus or a plus in it with a trig function. So what's the opposite? It's going to be 1 plus sign. What you do to the bottom, you do where? To the top. All right, now, don't worry about multiplying cosine times sine and all that stuff. Just stick it together. Just write cosine theta and then 1 plus sine theta. Now we can FOIL. We're thinking algebraically, so we're going to FOIL. What's 1 times 1? 1, okay. What's 1 times negative sine? Minus sine theta. What's sine times 1? Plus sine theta. And then what's sine times sine? Minus sine squared theta. Now, what do you guys notice happens in the middle? Your sines cancel out. So do you see how we're left with 1 minus sine squared on the bottom? You guys see that? Okay, so why did we do that? Well, can we cross off anything right now? No. But is there a Pythagorean identity that has a 1 and a sine squared in it? Oh, it's the one that we've used already twice this class period, correct? Sine squared plus cosine squared equals 1. How can I rewrite that so it says 1 minus sine squared? I'm going to subtract the sine squared, right? So this would be cosine squared equals 1 minus sine squared. What can I replace this with, guys? Cosine squared. Do you see that? So I have still cosine on the top. And then I have cosine squared on the bottom. Thoughts? Cancel out what? Cancel out one of the cosines? Yes. Okay, so this one cancels out and this one's gone. So I'm left with 1 plus sine of theta over cosine of theta. Now, at the very beginning, I said to you guys, just talk for a second. What was secant the same as? 1 over cosine. What's tangent the same as? Sine over, okay. Say it again. Is 1 over cotangent, right? Yeah. It's also, depending upon, 90% of the time, you're going to use the sine over cosine. You're going to use what? Sine over cosine, because it's the most basic of your trig functions. Hold on a second. Yep. All right, let's think about this for a second. I'm going to go back to algebra again, okay? Say I have this. 4 plus the square root of 3 over 5. What's another way I could write that? 4 over 5 plus the square root of 3 over 5, right? You guys, everybody okay with that? So can I split this up? What's another way I could write this if I could split it up? 1 over cosine plus what? Sine over cosine. How come I could split this up here, but I couldn't from the very beginning? I told you guys right here you couldn't split this up. How come? Because of the minus sign. Yep. If it's just one term in the denominator, you can split it up. You could split up into 10 different things if there was 10 different terms. So now what, guys? What is 1 over cosine the same as? Secant, right? And what is sine over cosine the same as? Tangent, which is exactly where we were trying to go. You can use one side of the equation to kind of guide you to the other side. You can keep looking back and being like, okay, wait a second. I kind of have a roadmap here. Kind of have a way that I can see, oh, okay, this makes sense. And again, this is not easy for everyone. I understand that. And you guys are going to have to practice this. Absolutely, you're going to have to practice and practice and practice. But it will get easier because you start to see repetition and stuff. Let's look at this one, all right? This one's kind of hard. This one's a little hard, but you guys can do it. I have 1 plus cosine 1 plus cosine theta over cosine. And then I have tangent squared theta over secant, theta minus 1. All right, couple things I want to talk to you guys about. All right, first of all, most of the time you can just start with the side that's the hardest and it'll simplify to the easier looking side. Most of the time. Sometimes it doesn't always work, doesn't always happen. So let's just look at this for a second. Which side looks harder? The right-hand side, because why?
Because you can cross off cosine.
Well, no, you can't cross off the cosines. But why is the denominator on the right harder than the one on the left? Because there's two terms, right? There's a minus sign. But just thinking from what we just did, you don't have to do this at the beginning. I just want you to start to see things. Can I split this one side up, the left side up? Mm-hmm. Why? Because, well, there's a plus. Yeah, but why can I split it up into two fractions? Because there's only one term in the denominator, right? I could split this up into 1 over cosine theta, right? Plus cosine over cosine. You guys agree? Could you simplify that even more? What's 1 over cosine the same as? No, 1 over cosine. Secant, right? Plus what? Plus 1. Now, if you did not do that from the beginning, that's fine. I just want you guys to start looking and being able to see things ahead of time. If you didn't do that, no big deal. You could leave it just like it was at the beginning. Actually, I'm going to erase that. That'll come back to us, but I'm just going to erase it. I just want you guys to see stuff. So if I start on the right-hand side, because we said that one's harder, all right? This is just like the last problem. I have a secant minus 1. So what should I multiply? Secant plus 1. Perfect. We're going to get rid of that. We're going to go to the conjugate. We're going to create our own identity here. So you don't have to multiply. You don't have to FOIL that all together. Just say tangent squared. And then secant plus 1 over. Let's FOIL this. What's secant times secant? Secant squared. What's secant times 1? Plus secant. Good. What's negative 1 times secant? Minus. And then what's negative 1, positive 1? Minus 1. What happens to your secants in the middle? They cross out. So you're left in the bottom here with secant squared theta minus 1. Everybody with me? All right, I have a trig function that's squared attached to a plus or minus 1. Is there an identity that you can look at? What identity involves secant squared and a 1? Say it again. 1 plus tangent squared equals secant squared. Okay, well, does that help us at all? How come? I could subtract the 1. Great, Judith. Subtract the 1 from both sides. So what does secant squared minus 1 actually equal? Tangent squared. Everybody see that? So I'm going to replace this with that. So I have my numerator of tangent squared theta times secant theta plus 1 over a denominator of tangent squared theta. Anybody notice anything?
You can cross that thing.
I can cross off my tangent squares. Perfect. All right, so now I'm left with secant theta plus 1. All right, so you guys got all the way down here and you looked up and you're like, what? Why isn't it the same? All right, most of the time, it'll work out that once you do the harder side, that it just is equivalent to the easier side. But that's not the case in this one. But remember, at the very beginning, we did a little bit of pre-thinking, right? If you get to this point, you're like, now what? Well, look on the left-hand side. I have one term in my denominator. What does that mean I can do? I can split it up, right? We just did this a second ago, but let's redo it. What do I split it up to? 1 over cosine plus cosine over cosine. What's 1 over cosine the same as? Secant. What's cosine divided by cosine? Are they now the same? Yes. Now, in all actuality, that took us 4 steps. All right, these are not easy. I'm not sitting here telling you guys, this is so easy. I don't know why you just don't get it. I understand this is not super simple. But the more you do this, the easier it will become, I promise. Go ahead and let's pull up your homework. Pull up the practice part 2. Practice 1, part 2. Pull up practice 1, part 2. This is due it by the end of class tomorrow. I'm going to do all of them with you, but it doesn't really help if I just do them all and just copy them. Try them tonight. Yeah, part 1 we did yesterday. And then part 2 we'll start now and then we'll finish it tomorrow. You got it? All right, let's go through our list of things that we should think about. First of all, your identity should be on here. But the first thing I look at is, and I say, do I have anything that is squared attached to a plus or minus 1 or anything like that? No. Do you guys have any plus or minus signs in here at all? No, then that makes your problem much easier. Because you know it's just multiplication. Which side looks more difficult? The left-hand side, for sure. So if I don't have any pluses or minuses or anything like that, I'm just going to break down to the 2 simplest trig functions we have, which are sine and cosine. So leave your sine squared. I'm going to leave sine squared x. I'm going to put it over 1, just because we're dealing with fractions, so sometimes it's good to make sure you have a numerator and a denominator. So divided by, what's another way I can write tangent? Now, to Bella's point, there's 2 ways you can write tangent, correct? 1 over cotangent, which, will that help us if we do that? No. If we had a bunch of cotangents in our problem, that would help. But since we don't, let's go to what? Sine squared over cosine squared. Okay, good. Now we think algebraically, guys. This is a fraction divided by a fraction. So we do what? You keep sine squared x over 1. You change division to multiplication, and you do what? Flip. So this becomes cosine over. All right, so when we keep change flip, cosine goes on top, sine goes on the bottom. So now what do you guys notice? Sine squareds do what? They cancel, and what are you left with? Just cosine squared, which is where were we trying to go? To cosine. All right, so when you start off with no plus or minuses or anything like that, it's super simple. A lot of these are simple. The next one is hard, I know that. But anytime you have a fraction that has a denominator that has 2 terms, like something minus something, multiply by the conjugate. Whenever you have something that has 1 term in the bottom, like say you have 1 plus cosine x over sine x. What's another way I could rewrite that? 1 over sine x, good, plus cosine x over sine x, which, if I kept going, what does 1 over sine become? This is a separate problem. I'm just making something up. What does 1 over sine become? Cosecant? What's cosine over sine? Cotangent? So look, these 2 things are the same. They don't physically look the same, but mathematically they are the same. So you have to be able to think algebraically. If you have 1 term in the denominator, you can split apart your numerators. It's when you have 2 in the denominator, that minus sign messes everything up. The minus and the plus messes everything up, so just multiply by the conjugate. Okay? All right, try.